Hi again. I had to cut that last video a little short because I'm limited to 10 minutes on these videos, but I just wanted to pick up a couple things and maybe go a little more into detail with a couple items in the workflow generator. So I trailed off at the end with these export data sets, which I'll show once we introduce how to access your storage drives on Hypergator using something like WinSCP or FileZilla, depending on the platform, either Microsoft or Mac OS X that you're using. I'm on a Mac, so I use FileZilla to access the server and kind of navigate my way through the file system just like I would on a Windows Explorer, for example. So these last two steps that I cut off at the end are exporting the log files or exporting the GenBank files and the GFF files from the Procus step to one of your shared folders. And if we click on this, you can see where you would specify that. So it says here, output file name and the folder. So you could set this based on your home directory and where your shared data lies. And again, we'll go into that a little more detail when you have a better understanding of how that file system is put together. So just as an example, and I mentioned this, there's three exports here: the assembly FASTA file, the GFF file, and the GBK file. And if I was working on this, and again, using the Klebsiella pneumonia example, I would have a folder called KPC or Klebsiella pneumonia. And underneath that, I would have something that says assemblies and annotations. And in the assemblies, I'd put all these FASTA files and export them from the workflows there, and then under annotations would be either all my GFF or GBK files that would dump into there. And again, that could be something for long-term storage or a place where you could then aggregate data so that in the future, when you wanted to use them in something like pangenome analysis, you could just import them all. Or if you wanted to download all of your FASTA files for a project and then run some type of analysis to do phylogenetics on them, they would be available in one place. Uh, let's go in a little more detail in Proca, and I'll show you a couple of the different options here since there's so many things. So we can change the label, and maybe I'll do that here. So we'll call this annotation with Proca, and we can save that. Again, always good to save your work often. And we can see that there's a number of different options. So the one thing we're going to leave blank is this locus tag thing. And that's basically how it numbers the different CDSs in there. And we want all of them to be unique, so I'm going to let Proca do that for me, and it's going to generate a random number to annotate those CDSs. There's one other thing that's worth noting here. You'll see these little arrows, and this allows you to either set something at this stage in the workflow. So if I change this to, let's say, just say Proca, then every time I run this workflow, it's always going to use the same value in there, Proca, and then whatever. And it could be Proca underscore, and when it does the CDSs, all the CDSs are going to be Proca 1 through 100. Excuse me. However, if I change this and click this little arrow there that says set at runtime, and you see now that the arrow direction changed from up until down, then every time I decide to select this and run this workflow, it's going to prompt me at the first step to fill in a value for that specific field. So that way, if you're running things one at a time, or later when we show you how to batch run these workflows on a set of data or a data library, then this would allow you to set unique values at that time. And this is true for any variable on here where you see one of these areas that says set at runtime. So that's a good little point with this. So I'm going to leave that open again so that it just uses a default value in there. A couple other important pieces for at least Proca. This says minimum config size, so it'll ignore anything that's smaller than 300 base pairs. You can change this. This is probably a moderate value. There are certainly some species that have coding sequences that are smaller. I know, for example, in Staph aureus, there are things that are around 150 base pairs. So that's something to take in consideration, and knowledge of your species that you're working with would come in handy there. There's a couple values, genus name and species name, which I do have selected to run to set in at the time of running. And that's important so that this workflow can work for all of your genera that you're working with. So I could run this with Staph aureus, or I could run it with Streptococcus pneumonia, or Klebsiella pneumonia, or Salmonella enterica. And when I go to run this workflow, I'll enter those names and the genus and species in there at the runtime. And here is some more advanced little coding for Galaxy. Is if you put something in there like this, and there's a page that I could link that has some more information about this, but you'll see I have this hash or pound symbol here, parentheses, and then I have input and a bar, and then base name, and this is all bracketed in there. And what I'm telling it is to in this field for strain name is to use the name of the input file that is coming in this area right here, the contigs to annotate. And so if I call this strain one, and my FASTQ files are strain one underscore one FASTQGZ and strain one underscore two FASTQGZ, then my strain name will be strain one at this step. So that's a little useful code that can come in handy in multiple places when you want to rename files that as they're either rename fields or rename files as they're being exported to the next step. Let's see. And again, as I said, there's a lot of options in here. Most of them are staying default, and some of the other ones I've changed to make sense for this specific workflow. So again, we're going to go ahead and save this. And this is an example of a more detailed but pretty simple workflow. We can even, you can see, I'll go over real quick, Gren, where you can add things. So maybe you want to blast. You wouldn't necessarily do this on an entire de novo assembly, but you could use blast to assess your either one of your annotated files, or I'm sorry, one of your assembled files or a piece of that. So if you click on this, you'll see that BLAST-P now emerges, and then you could take another arrow from this de novo assembly and drag and drop it over here. And it would run now BLAST-P on that. If you wanted to get rid of this step, you just go ahead and hit the X, and that disappears. So it's fairly easy to add things on to analysis. Now, it is important to know that if you want to organize this and keep things nice and simple, then when you have this this step right here, if you put it right here, it'll appear in the workflow history before the annotation with Proca step. If you drag and drop this to the other side, then now it's going to appear after the Proca annotation step. So it's just something to keep in mind if you're ever building one of these workflows and want to keep it organized. So let's save this, return to our workflow, and we will pick up next time at running one of these workflows. All right, see you guys later.